In this last part of our study of rational exponents, I just need to remind you of some things you already know. You know that x squared times x cubed is x to the fifth, because if you're multiplying and the base numbers are the same, then you just add the exponents. And that property is true no matter what x is or the exponents are. So it carries over into these three problems. In the first problem, we have 2 to the 1/2 times 2 to the 5/2. Well, bases are the same when multiplying, so altogether this would be 2 to the 6/2. But 6 over 2 is 3, so this is just 2 to the third, which is the same thing as just 8. In the second problem, we have x to the 2/3 times x to the 4/3. Bases are the same and we're multiplying, so the exponent would become x to the 6/3. But 6/3 is the same as 2, so we can write this as x squared. In the last problem, z to the 3/4 times z to the 5/4. Well, this is z to the 8/4, but 8 over 4 is 2, so this becomes z squared. Let's look at a different idea. Recall that x squared to the third is an example of power to a power. And this becomes x to the 6th, because in power to a power you can multiply the exponents. And this carries over no matter what the base is or the exponent. Here are 3 examples where the exponents happen to be rational. Well, x to the 4th to the 1/2 by power to a power is x squared, because 4 times a half is 2. Y to the 6th to the 1/3 is y squared, because 6 times a third is also 2. Z to the 9th to the 2/3, well, that would be z to the 18 over 3. And 18 over 3 is just 6, so it just becomes z to the 6. So power to a power is exactly the same, even if the exponents are rational. Let's look at one more. Here the base numbers are the same and we're dividing. So we'll just subtract those exponents. X to the 5th over x cubed is x squared. Remember that if it was the other way around, x to the 3rd over x to the 5th, we would still subtract because the bases are the same when we're dividing. And 3 minus 5 is -2 in this case. So things that are similar, even though they're rational exponents, are x to the 1/3 over x to the 4/3. Well, that would just be x to the 3/3, which is just x to the 1st. In the second one, we have y to the 3/4 over y to the 1/4. Well, that would just be y to the 2/4, which is the same thing as y to the 1/2. And this is the correct answer as far as exponential form goes. We could write it as the square root of y if we wanted to, if we wanted it in radical form. And the last one, z to the 2/3 over z to the 5/3. Well, that would be z to the -3 over 3, which is the same thing as z to the -1. And that negative means take the reciprocal of the base. So it would be 1 over z, all to the first, which is just 1 over z. Our exponent properties haven't changed at all.